This is the final video project for engineering materials in spring of 2022. Our presentation today is on solutions for polymer waste by Nicholas Jones and Timothy Searcy. Your guides today on this journey of discovery are myself, Nicholas, and I am a sophomore at Louisiana Tech University and am majoring in nanosystems engineering with a focus in chemical engineering. I like reading books, drinking coffee, and memes about the futility of life.
I am Timothy Searcy. I am a sophomore at Louisiana Tech University. I'm a nanosystem engineering student with a focus in biomedical engineering. I like hiking, studying, and stressing over classwork.
Polymers' role in society. Plastics have provided an era of mass-produced products that are cheaper, last longer, and are more effective than products that are made from most other materials. The advancement of polymers in society has provided the unprecedented innovation in just about every area. Advancements in polymer technology have yielded tools like 3D printing and shrink wrap. There are a multitude of polymers or plastics in usage. Here, we'll cover some of the more common ones and their general usage. First, we have PETE, or polyethylene terephthalate, used for food containers and plastic bottles. Second, high-density polyethylene, used for detergent bottles, food and drink storage, and bottle caps. It's the stiffer plastics. Polyvinyl chloride, or PVC, is used for water and waste pipes, flooring, signage, and furniture due to its chemical resistance. Low-density polyethylene, used for containers, playground fixtures, and plastic trash bags. Polypropylene, commonly used in injection molding. And last, polystyrene, used in disposable plastic containers for food, as insulated containers and in packaging materials. Plastics have been enormously helpful in every industry, from healthcare to food preparation. They are used every day in almost every place there are people, but as the saying goes, there's no such thing as a free lunch. With the massive surge of plastic usage since their invention, there is an enormous problem with disposing of plastics. From trash on the sides of roads to massive landfills, innovation and creativity are needed to solve the problems of plastic pollution.
As a problem with waste produced by polymers, new trends for recycling them are underway that can reduce the waste output that is produced by these polymers. It is important to recycle polymers. As stated before, they are difficult to break down and decompose in the environment. With this in mind, it clutters everywhere that they are found, causing ecological damage. With new trends, businesses and people are turning to recycling to help reduce the cluttering and save the environment. Benefits to recycling include, but not limited to, saving the environment, creating new polymers or materials, uncluttering landfills, and using less resources for manufacturing new polymers due to the fact that we are reusing old polymers. An outline of the processes taken to be taken in recycling of polymer plastics is as follows. Traditional ways, which is what we're used to. These are the ways in which we already use, which include melting polymers to create new polymers to be used, or could be ground up and mixed with different materials to create new products. Flash drill heat, and then recycling thermosets. Now for flash drill heating is a newly researched process being brought into development as a new way to recycle polymers. First, it requires that you grind up the plastic into a powder that has a particle size around 1 to 2 millimeters, as it is the most ideal size for the process that is about to take forth. The next step involves applying AC current to the powder for 8 seconds, as this would increase the temperature high enough to break down and form low-quality graphene. During the pulses produced by AC current, the material will undergo rapid cooling, which prevents the graphene from forming into layers. Then you apply a DC current to the newly formed low-quality graphene to produce high-quality graphene for 500 milliseconds, as this will greatly increase the temperature to produce better quality graphene. High quality graphene is important as it is 200 times stronger than steel. With this process of recycling being implemented more and more, we can start making graphene sheets and flakes more and more available by lowering the cost and making it more available than just for research purposes, maybe even for future building materials.
Not all plastics can be recycled by melting them down. Specifically, thermosets form chemical bonds when they are heated, and after they are set, only degrade when heated. Researchers at MIT created a degradable polymer for drug delivery by incorporating a building block or monomer containing a silyl ethyl group. This monomer is randomly distributed throughout the material, and when the material is exposed to acids, bases, or ions such as fluoride, the ether bonds break. The same type of chemical reaction used to synthesize those polymers is also used to make some thermoset plastics, which are used for body panels in trucks and buses. Using this same strategy, they were able to add the ethyl monomers to the liquid precursors for forming the plastics.
Thank you for joining us in this journey of discovery of interesting facts and new methods of plastic waste management.